In this video, we're going to take a look at differential pressure transmitters. I'll explain to you briefly how they work, what applications we use them for within engineering, and then I'll talk about some of the problems that you might have when you're using DP transmitters. Here's our DP transmitter. We've got some flushing valves here, also known as blowdown valves. Got a different valve over here, another one up here, and we've got connections to the top of our steam drum and the bottom. This might also be a closed pressure vessel, could be an open vessel if we put a vent in there somewhere, but we're going to assume that it's a steam drum. The low pressure connection is the one up here. That connects to our vapor space, a gas space, which is the top part of the steam drum. If you're working on the DP transmitter and you have drained the reference leg, you will have a bolt on top, like this one here, which you can remove in order that you can fill the reference leg up with water again. Remember, if you start the boiler and the reference leg is empty, you're definitely not going to get the correct reading. So you remove the bolt on the top, you pour water into the reference leg. Once it gets to a certain height, roughly where my mouse is now, the water will begin to flow back into the boiler steam drum. This is where it gets quite interesting. Steam easily condenses back into water when it cools down. That means that if we were to have a reference leg that connects to the top of the steam drum, steam would enter our reference leg, then it would cool down. The reference leg's quite often away from the steam drum itself, and that means that the small pipe that forms our reference leg is cooled down by the ambient air, the steam condenses to water, it accumulates within our reference leg, and then the reading that we're getting from the low pressure side of our DP transmitter is totally inaccurate. So that's not good. Sometimes a DP transmitter might be installed outside. Sometimes it will be insulated, sometimes not. It depends upon the conditions, the ambient environment in which the DP transmitter is present. If the reference leg is surrounded by a very cold ambient environment, for example, if the ambient environment is at minus 20 degrees Celsius, which is minus 4 degrees Fahrenheit, then the condensate within the reference leg will begin to freeze. If that happens, the measurement that we're taking on the low pressure side of our DP transmitter is, once again, totally inaccurate.